Good evening, everyone. My name is Noah Marinaccio, and today I would like to talk to you guys about open channel flow. An open channel flow is a type of fluid flow. And in fluid mechanics, we actually talk about two types of flow. One in an open channel and one in a closed channel, also known as pipe flow. In an open channel, what distinguishes it from pipe flow is that in an open channel, we have a free surface. As you can see behind me is the Hudson River. The Hudson River is one of the greatest examples of open channel flow in a modern system. And we see throughout all of nature in the world, rivers, streams, oceans, that open channel flow is a very, very common phenomenon. However, we want to learn about how we can talk about it in terms of math and science. And join us now as we discover open channel flow and we talk about the different properties and equations that can go into calculating certain things about open channel flow. And hopefully you guys will gain a better understanding of it.
I'm Matthew Komazinski, and I will be talking about Reynolds number. What Reynolds number is it's a property of open channel flow that tells you whether the flow is laminar or turbulent. When Reynolds number is above 2000, that means that it is turbulent, and when it's below 2000, that means that it's laminar. The Hudson River is a turbulent flow, and you could tell just by looking at it because of the bumps that are in the water, and instead of it being steady and flat, that would be laminar.
Guys, I'm Reynold. So I'm gonna talk about the Froude number of the open channel flow. Froude number is the dimensionless quantity that's used to indicate the influence of the gravity on the flowing motion of water. It is also the ratio of the inertial force on gravitational force. So for the Froude number, we can determine if the flow is supercritical, subcritical, or at critical states. So if the Froude number is bigger than 1, then the flow is supercritical. If the Froude number is lower than 1, it is a subcritical. And if the Froude number is 1, that is at critical stage. So the difference between supercritical and subcritical is that the supercritical is a fast-moving water and a subcritical is a slow moving water.
Okay, so when it comes to open channel flow, we've talked about Froude's number and Reynolds number. We have this general governing equation called Manning's equation, and it's given here two ways, one in terms of US units and one in terms of SI units. And what we have is 1.49 divided by n. N is the Manning's coefficient, which varies by the material that the channel is made out of, times cross-sectional area, times hydraulic radius, times the slope of the channel. Generally, we can figure out slope of the channel, we can figure out area, and hydraulic radius is given as the area divided by the wetted perimeter. So basically, the area in which water is touching the channel, that's called the wetted perimeter, and that's how we calculate hydraulic radius.
Alright, so here I'm going to talk about the Froude number equations. So for the Froude number equation, it is the ratio of the inertial force and the gravitational force. It can also be calculated by the velocity over the square root of the gravitational force and the diameter of the channel. And to determine the flow for the Froude number, if the inertial force is bigger than the gravitational force, then the flow is more into the supercritical phases. If the Froude number is bigger than 1 or the inertial force is smaller than the gravitational force, then the flow would be a subcritical. And if the Froude number is equal to 1, then the flow is at critical stage.
Alright, so this is how you would find Reynolds number. You would take the velocity multiplied by the diameter over the kinematic viscosity. And the kinematic viscosity is the ratio of the dynamic viscosity and the density. So for Reynolds number, to figure out if it's laminar or turbulent flow, normally when it's below 2100, then it's laminar, and when it's above 10,000, then it's turbulent. And in between that is kind of a transition phase where it's both laminar and turbulent.